Hey guys, we're going to talk about evaluating piecewise functions. So we just did a little video on increasing or decreasing, and we looked at those. So we want to talk about how to evaluate when x equals something. So this piecewise says p of x, and then it tells you if x is less than 0, we're using this function 2x. If x equals 0, we're using x plus 5. And if x is greater than 0, we're using 0.5x minus 1. So when they're saying p of 10, what they're saying is this x right here is 10, right? So x equals 10. When p of 10, wherever x is, we want to put a 10. So we're going to go over here and look in our, and remember I tell you I like to put the lines. If you can see without the lines, don't do the lines. I teach it to numerous people all the time, and the lines seem to help a lot of people, so I always do it. And I say, okay, is 10 less than 0? Nope. Is it equal to 0? Nope. It's greater than 0. So I'm going to use this function here, and I'm going to plug in 10 as x. So 0.5 times 10 minus 1. So 0.5 times 10 is 5, and then minus 1. 5 minus 1 is 4. So when x is 10, the answer is p of x, or p of 10, is 4. So the same exact thing for each and every one. So now we have, okay, what about when x is negative 10? So we're going to go over here and say, well, it's less than 0, so I'm going to plug it into this one. So negative 2x, so negative 2 times negative 10. And that's going to be negative 20. So p of negative 10 is negative 20. And this is super hard to see, but this is a 0. Sorry. All my other letters are big, or numbers are big. That one was kind of small. Now it just looks like a hole in the ground. So p of 0, we come up here and we say, okay, not less than, oh, it's equal to 0. Well, x is 0. So it's x plus 5, which is so crazy. So x is 0 plus 5. So 0 plus 5 is 5. So p of 0 is 5. All right, last one. X equals 2.48. So p of 2.48. So it's still greater than 0, right? It's a positive number. So I'm going to plug it into this function. So 0.5 times, and where the x is, I put 2.48 minus 1. So half of 2.48, or 0.5 times 2.48, would be 1.24. Okay? And then bring over that minus 1. And that would be 0.24. And that's it. We tell you what x is, you tell us what f of x is, right? So if x is negative 3, where does it fit here? Well, negative 3 is less than 2, so I'm going to use this one. So it would be 2, and where x is, I put negative 3, plus 1. Well, 2 times negative 3 is negative 6, plus 1 would be negative 5. And when I have a table like this very well-drawn table that you see here, what I usually do is I look for the cutting off point, because I kind of get in the habit of like, okay, plug it in, plug it in, plug it in, plug it in, wait. And if you don't make your line early, then you have to check each one. Okay, negative 2 is still less than 2. Negative 1 is still less than 2. So what I do is I say, okay, everything less than 2 is this function. Well, here's 2. So everything here back is this function, 2x plus 1. And then when it equals 2 or it's greater, these boxes, I'm going to use this function. When they're in order, if they're not in order, in x order, then no, I'm not going to do that. But in this case, we can see that they're clearly increasing. So negative 2, everything from this line, I'm plugging right into this formula, 2x plus 1. So 2 times negative 2 plus 1. 2 times negative 2 would be negative 4, plus 1 would be negative 3. And I'm just going down, up, because there's not a lot of room on the paper. So 2x plus 1. So 2 times x is negative 1, plus 1. 2x plus 1. So that would be negative 2 plus 1. That would be negative 1. Here I have 2 times x plus 1. Plug in my x. Well, 0 plus 1 is 1. Here I have 2x plus 1. Plug in my 1 as x. That would be 2 plus 1. That'd be 3. One more time, 2x plus 1, and now I have 1.5. 2 times 1.5 would be 3, plus 1 would be 4. Now I can already tell that this is increasing because it has a positive slope. But I can also look here and say, okay, when my x's are getting bigger, well, my y's are getting bigger. So that's increasing. Cool. Now I go over here to these last parts and I say, okay, now I'm looking at equals 2 or greater than 2. So now I'm using x squared minus 2. So I'm plugging as 2 as x. So 2 squared is 4 minus 2 is 2. Now this one looks complex, right? You're like, oh, the square root of 5? Seriously? But think about it. X squared minus 2. A square root square cancels out, right? The square root of 5 squared would be 5. So 5 minus 2 would be 3. And then last one down here, we have x squared minus 2, and I'm plugging in this 3. Well, 3 squared would be 9, minus 2 would be 7. And I could tell here again, as x increases, y increases. And I can look here and say, well, this is going to be a parabolic shape, right? It's going to be a u, but I'm all on negative numbers. And so my lowest number here is 2, so yeah, now I'm good. Totally increasing here. Because I'm starting right over here on this part of it, right? So, if I said, hey, when was this increasing and when was this decreasing? You would come in here and say, all right, well, it's increasing always, and it's decreasing never. But we don't say always, and we don't say never. I mean, here we just say no decrease or never, that's fine. But here we would say, we would either do an interval notation, and again, disregard the ugliness of my infinities, or we could say x when x is a real number, and I'm doing the number sign because I don't want you to sit here while I have to write out a number. All right? So you are just taking p of, f of, whatever that is, and making it x, and then solving the function for which it applies. So these numbers are all less than 2, so we used the function for when x is less than 2. These numbers are 2 or more, so we used the function for when x was greater than or equal to 2. So piecewise functions are one of those things in math that look crazy when you look at them. Like on a graph, in person, they just look insane. Like if somebody gives you this and they're like, cool, solve for 3, you're like, what? No, that's crazy. But break it down and say, okay, well, if x is 3, which situation does it fit into? Oh, it fits right here. So I just have to plug in 3. If x is 0, it fits in here. So I just plug in 0 as x. And if it's a negative number, oh, it fits here. So I just plug it in as x. And the math part of it, you guys are good on. It's just looking at it and seeing what you're supposed to do. So I hope that this helped. This was for a couple people that missed the live presentation. So I just did a couple, and let me zoom out. I just did a couple of the first 2 examples, just so you could kind of see what they looked like. And then we did the same thing on the back. We literally plugged in 4 to, I think there's 5 or 6 on the longest ones, 4 to 5 or 6 values for x for each piecewise function. And then we ask for each one, when is it increasing and when is it decreasing? And so you're either giving me specific portions, or you're saying always, or you're saying never. And by always, I mean this. Most people like the interval notation because it takes a lot less time, but you are welcome to put it in set builder notation as well, whichever one works for you. All right? Have a good day.